dogs and workers in drones, but they prefer to reproduce on drones because they can reproduce better there. And we know that if we keep our mite population low continuously, we can keep those virus problems in check. But if we let the mite population skyrocket, and therefore the virus population potentially skyrocket, then even if we kill those mites, we're not necessarily going to be solving our virus problem. We know that mites can spread from a treated colony, or from an untreated colony into a treated colony, or from a colony that has mites to a colony that doesn't. So if I kill all of my mites this year, that doesn't mean I've solved my mite problem. It just means that I've managed it for my hives for that period of time. And of course, when our mite levels are really high, even if we kill every mite, we're not killing every virus. So we might kill every mite in a sick colony and still have them die, and it would still be the mite's fault, even though the Varroa mites are all gone. So these are the treatment recommendations that we give when folks ask for them for the Northeast US. And so we say, if you're doing the sugar shake or the alcohol wash, one of these sample methods, and you're doing it in May, and you're finding 6 mites or more, so more than 2% mite infestation, that's 6 mites per 300 bees, or 2 mites per 100 bees, then we recommend that you do a treatment. If you're finding 4 mites per 300 bees, then it may not be necessary to treat. This is the economic threshold that's been established by research. And you need to be aware that there are mites in there, but you may not need to go in and jump immediately to a treatment. But once you get over 6 per 300, yeah, we would recommend it. If you're doing the sticky board, as I said, it's a lot harder to really know exactly what the mite population is there. But the general recommendation is for a typical colony, if you have 9 mites falling per day or more, we would recommend that you treat at that point. If you're doing these monitoring steps in August, you can actually tolerate slightly higher mite levels. Because in August, we expect that the mite population has climbed, but 3% mites in August is not going to be 70% mites in September. They don't have that much more time to grow. And so you might be able to withhold that treatment if you've got 8 mites per 300 bees in August. But I would really recommend that you just stick to this. You just try to stay below 2% infestation. So that's less than 2 mites per 100 bees, or less than 6 mites per 300 bee sample throughout the year. And the folks that I have talked to who have the most success managing mites are using this as their threshold. They're just trying to make sure the mite levels never get above that 2% threshold. So let's talk about mite management. Let's talk about mite control. And we'll start with chemical control, because it's in many ways the easiest and most foolproof mite control methods you can use. So there's a lot of miticides on the market, and that might seem great. You look at this and you say, oh geez, we talked about this terrible parasite. Well look, we've got all these different things we can use to kill them. But then you might sit for a moment and think, why would they keep making mite killing products if the first one worked? And the reason is that the first one doesn't work anymore. So the first mite control product that was registered was Apistan, fluvalinate. And it went in, it was a miticide, it killed mites, it didn't kill bees, it was terrific, until it didn't kill as many mites. It started killing 99.9% of Varroa mites, and then it killed 99% of Varroa mites, and then it killed 98%, and then it killed 96%, and then it killed 78%, and then it killed 45%. So these mites very quickly evolved resistance to Apistan, because it was the only treatment that was being used, and it was being used over and over again, and it was being misused. Too much of it was being put in, it was being used constantly, and so the mites that survived it, the only mites that could survive it, were the ones that had offspring. So that's where resistance comes from. So then the next mite product was Checkmite, Coumaphos, and you could buy that. It was a product that would kill Varroa mites until they evolved resistance. And they evolved resistance even faster than they did to Apistan. Coumaphos also contaminates wax and leaves a residue that lingers for a very long time. So there's some other downsides to it. The next synthetic pesticide that most folks talk about is Apivar, or an amitraz-based miticide. And so Apivar is the brand name, amitraz is the chemical name. There are increasingly reports coming in that some people are seeing reduced effectiveness of amitraz. Now, I don't want to suggest to you that we're only 2 years away from amitraz having a line struck through it. It's a good miticide, it's an effective miticide. As long as you manage it appropriately, it can be a good part of your mite-killing toolkit. But if we only used amitraz, and we put amitraz in every colony and it was there all the time, if any Varroa mite was ever going to be able to survive it, those would be the mites that had daughters. And then that's how you select for effective resistance. So we've got to be more responsible with this than we were with the Apistan fluvalinate. There was also fenpyroxamate, Hibistan. It was a great product. It killed lots of varroa mites. It also killed lots of bees. And so that was taken off the market. All of these others here, formic acid, thymol-based products, oxalic acid, or hops beta acids, these are all approved for use to control varroa mites, but they have some issues. Some of them might be dangerous for the applicator to put on. Some of them might be a little dangerous for the bees, might kill some of those bees. Some of it could risk honey contamination, and some of them might just not kill as many mites as some of those other techniques or methods we talked about. Amitraz might kill 99%, maybe the hops beta acids only kill 50%. Is that okay? Well, as long as you understand it and plan for it, maybe it is. But I want to talk about each of these very quickly just so that you feel comfortable using some of these products that maybe you've never tried before. The first thing I do need to emphasize, though, is the label is the law. Nothing that I say to you now or that anyone ever says to you about how to control varroa mites can supersede what's printed on the product that you bought to treat your bees, to treat for varroa mites. So if I tell you to use avibioxyl, which is the labeled legal oxalic acid treatment that you can put onto your bees, and I say that you should do a rain dance before you use it, and you should use 40 times the recommended dose, and you should mix it with turpentine, don't listen to me, listen to the label, because the label is the law. So let's quickly just talk about each of these and make sure that we've all got a good sense of how they use some of the pros and cons or the techniques that you might use for them. So this is Amitraz, and you're going to buy that in the form of Apivar, which is a strip of plastic that is impregnated with the active ingredient, with this miticidal chemical. You can use it at a pretty wide range of ambient temperatures, about 60 to 100 degrees Fahrenheit outside. You cannot use it while you've got honey supers on. And what's more, if you treat with this, you can't put honey supers on the day that you take the strip out. You've got to leave it for an additional withdrawal period before it's safe to put those honey supers on. Because this is a synthetic pesticide, and we do not want synthetic pesticide residues winding up at the local farmer's market in our honey. And so it is an effective mite control, but it's something that you need to really plan for because it might take 55 days before you can actually put a honey super onto a colony that you've started treating with this. It kills only the phoretic mites, only the mites riding around on the bees. However, it's in the colony for so long, releasing that miticide, that all of the mites that are on the brood are eventually going to come out, and then they'll make contact with you. So it's in there long enough that it's okay that it's only killing the mites on the bees. Another product, a product that I really like, is formic acid-based miticide. There are two products you can buy, Mite Away Quick Strips or Formic Pro. They're both made by the same company. This was their sort of Model 1, this is Model 2, but for some reason they're still making both of them. But really Formic Pro is in a lot of ways just an upgrade and an update to the Mite Away Quick Strip. The trick with these is that the ambient temperature cannot be below 50 degrees and it cannot be above 85 degrees Fahrenheit. Because if it is too cold, the bees are going to be in a cluster and they can't fan their wings and circulate the oxalic or the formic acid vapor that is escaping from these pads that are impregnated with the formic acid. If the temperature is above 85 degrees, too much of that formic acid will come out too quickly and the bees will get overwhelmed by it. It will kill a whole lot of varroa mites, but it will also kill a whole lot of bees. This is safe to use with your honey supers on. And this does kill varroa mites that are underneath the brood caps, as well as varroa mites that are riding around phoretically on the bees. And so it's a very effective treatment as long as you're within that temperature window. And so it's something that I think everyone should have a good understanding of the pros and cons of using, because for some people it might very well be the perfect miticide for a particular hive that you need to treat today. And I'll just emphasize that formic acid is an organic acid. It's a compound that's naturally found in honey and naturally found in honeybees. Honeybee stings, honeybee venom actually contain some amount of formic acid. And so this isn't a chemical that's completely unprecedented in the biology of the honeybee. Obviously, this is a much higher dose than they're ever going to encounter. But if you've ever taken a carpenter ant and smashed it and sniffed it, that smell is really the same formic acid that these honeybees are going to be experiencing. Thymol is another product. It's marketed either as Apogard paste or as Apolite var, which are these little briquettes, I guess you call them. Some folks call it thymol. I call it thymol because it's made from the thyme plant, the herb thyme. But you can call it either way. This is not safe to use with honey supers on because it's going to contaminate the honey and the wax and it's going to give it an off odor. So you don't want to be making honey for consumption with your apron guard on the colony. However, it does kill varroa mites. It's going to kill only phoretic mites while the treatment is on. But the bees are going to go up, they hate the smell of thymol. That's the way it works. They go up here and they're desperate to rip off these little pieces or to scoop out some of this paste and to carry it away. And while they're doing that, they're getting it all over their bodies, they're sprinting it all over each other, and then this small amount of thymol is sort of percolating through the hive and appears to kill the varroa mites probably by becoming a vapor and then being absorbed through the thin parts of the mite's exoskeleton. Oxalic acid is marketed as apibioxyl. That's the legal labeled products that you can buy. I know some folks will buy wood bleach. I know some unscrupulous beekeeping supply companies will sell wood bleach for you to bleach your frames or bleach your boxes, and they know what they're doing. And the EPA knows what they're doing. The EPA is in the process of telling them they need to stop selling wood bleach as if it's the labeled tested product. But the oxalic acid that you use, ultimately both of these are crystallized oxalic acid. This is just being put through more rigorous inspections. The way you're going to apply it, if you choose to use the dribble method, is going to involve making a sugar syrup, mixing the appropriate amount of oxalic acid in, and then squirting that over the tops of your bees, over the seams of bees that are running in between all of your frames. And so your goal there is to put, I think it's 5 cc's per seam of bees with a maximum application of 50 cc's, 50 milliliters of this syrup covered with full of oxalic acid. It's going to cover the bees, they're going to clean each other up, they're going to lick each other, and it spreads the oxalic acid throughout the hive. It's going to kill only phoretic mites, but it is safe to use with honey supers on. That didn't used to be true, but it is now considered safe to apply oxalic acid to a colony that has honey supers on it. You can also use the vaporization method for oxalic acid. You can go in and you can take these crystals, you put them into a little heating element. So this is one of the wand style vaporizers, but there's also sort of a gun style. But in either case, you take your oxalic acid crystals, you put them into your heating element, you hook that onto your battery, you stick it into a hive that you've sealed all up, and that you've taken a piece of cloth and pressed against all of the entrances so that the vapor stays inside. And when you connect this to the battery, the heating element heats up, the oxalic acid sublimates, and then it creates this cloud inside the hive. And then it will very quickly recrystallize on everything it touches. It recrystallizes on the wood, on the mites, on the bees, on the wax, on everything. And so now you've again distributed these oxalic acid crystals throughout the hive. It's critical, though, to keep in mind that applying the oxalic acid, using the oxalic acid dribble method, realistically, you should probably wear gloves. You wouldn't want to squirt it in your mouth or in your eyes, but it's not very likely to cause harm to you. The vaporization method can absolutely cause permanent blindness or permanent lung damage if you're not wearing a respirator, if you're not wearing goggles, if you're not mindful of where that vapor cloud is, and that you're not standing in it. So it's critical that I know that people often will be sort of cavalier about their safety techniques in the apiary, and some of us don't wear veils because we're cool beekeepers, and we don't care if we get stung on the eye and go blind. But oxalic acid vaporization is a whole extra level above and beyond us being cool and getting stung on the face by bees. So it's critical to remember that if you're going to do it, you've got to follow the safety protocols, because this stuff can really, really mess you up. But the bees do pretty well. The bees don't suffer the same way we do when they breathe this in. And the varroa mites do. And so it's a good way to control, as long as you don't have very much brood in your colony. If you've got a lot of brood, a lot of the mites are going to be underneath the caps. This doesn't kill the mites that are under those caps. And so you just kill a few of the mites that are riding around phoretically, and you're not going to have brood control beyond that. The other thing that I want to talk about that has that same problem, that same issue, is the HopGuard 3, hops beta acids, which is a sort of a sticky, goopy product. It's sort of unpleasant to work with, although it's not terribly, the chemicals involved aren't terribly worrying. It's just that it's sticky. But you take this hops beta acid strip, you put it down into the hive, and it's going to, through making contact with bees and then being spread around, kill phoretic mites. It's safe to use with honey supers on because the hops beta acids are derived from hops, the same thing that you use to flavor beer, and obviously not mead. But the problem with HopGuard is that it particularly suffers when you've got brood, because it only kills those phoretic mites. It only has that brief window of control, and so the mites that are not in contact with it don't get controlled. And it seems like it doesn't really control mites very well at all if there are mites that can go, if there is brood that the mites can go into. A broodless colony treated with HopGuard seems to have much better mite control than a colony that's got some brood. So, we've talked about all of these. These are all of the approved methods that you can use to control varroa mites. Which of these chemical control methods is the best one? That's the most common question everybody asks me. Wrong question. The problem is, if you go in and say, I want to use the best miticide, I'm going to use the strongest one, or the most reliable one, or the easiest one, or the cheapest one, whichever you choose, you're going to wind up doing that same thing we did with Assay and with Coumaphos. You're applying just one pressure to your varroa mites, and you're going to encourage them to start evolving resistance to whatever you choose. Now, it's going to be harder for a varroa mite to evolve resistance to some of these chemicals than to others. But there's another downside to only ever knowing about and using one of these tools. Formic acid is a great mite control technique, but you can't use it if it's above 85 degrees Fahrenheit outside. So if you decide that it's bad because it sometimes gets hot in your environment, you're never going to be able to use a really good mite control tool because you've written it off. So what I want you to really do is think about these miticides as weapons in your personal arsenal. They're all good tools for you to have. They're all good tools for you to understand. And it might even be good to have a few on hand in your shed. But you've got to understand some of them might not be effective. Maybe there's some mite resistance, or mites that have evolved resistance to that chemical. They might not be very effective because they just don't kill that many mites. If you're using something like HopGuard and expecting 99.9% mite death, you're going to have a bad time. But if you're expecting 50%, and that's just part of your way to try to knock mite levels down a little bit throughout the year, then you might be very happy with it. Some of them are unsuitable due to the temperature. That's something like formicrom. Some of them are unsuitable because you've got brood. HopGuard 3 and most oxalic acid applications seem to be much less effective if you've got brood in that colony. And some of them are going to be unsuitable because you've got honey supers. And so that's going to be everything except formicrom, HopGuard, and oxalic acid. Those are the three that are approved to use when you've got honey supers on your colony. And so what I want you to really understand is that managing varroa mites, and that's your job, is to manage them, involves getting a lot of different weapons in your arsenal and then being ready to use them at the appropriate time. These are the chemical weapons in your arsenal. Sorry, this is just to emphasize again that if you're using amatraz and you keep putting strip after strip in the colony and never taking it out, it's going to select for resistance the same way it did for the others. So as I said, so that's the chemical methods. There are also some non-chemical mite control methods that you can learn about. Here are three of them that I don't particularly like, that people sometimes get all excited about. One of them is using a screened bottom board. They figure, I put the screened bottom board in, the mites fall down. If I just opened that to the ground underneath my hives, all of the mites would fall, and then the ants would eat them and I'd be safe. Well, the problem is most of those mites don't fall until the day they die. And so you're collecting a lot of dead mites that fall every day, but you don't have all that many living mites that are falling down. So this is not a control method, it's just a monitoring method. Some folks get excited about the powdered sugar test, and they think, well, if I took enough powdered sugar and I covered all of my bees with it, wouldn't that completely eliminate my varroa problem? Well, unfortunately, it doesn't work that way. If I took 25 pounds of powdered sugar and I poured it on a colony that had a lot of mites, yes, I would knock some of those mites off. But I'd probably have to go back and do that again the next week, and the next week, and the next week. And eventually, I'm putting 900 pounds of powdered sugar into a colony that I might get 50 pounds of honey out of. It's not a good varroa management tool. You can keep it off, but for the most part, it's not going to be as effective as those 300 bees in that jar getting swirled around and then shaken. It's just not going to be enough powdered sugar thoroughly covering enough of those bees. The other method that folks will sometimes talk about is using heat. There are various products that have said, well, we know that varroa mites are more sensitive to heat than bees are, so if we heat up the brood, or if we heat up the bees, or if we heat up the hive, then maybe that's going to help. The problem here is it's not a bad idea. Good research on that can and should be done. But we were talking about varroa, heat control for varroa, 10, 15 years ago? And we still don't have anything on the market that's actually proven that it controls varroa mites. And so that starts to make me pretty skeptical that the next big heat control technique is going to be effective. So just putting my colony out in the sun, or taking my hairdryer and blowing on them and trying to heat them up, I don't think that's a good mite control method. There are two non-chemical mite control methods that I do like though, that I want to talk about. Drone comb trapping and limiting your bee population growth. I'll talk about each of these. Drone comb trapping is a very, very clever way of short-circuiting those mites' behavior and taking advantage of some of their natural instincts. Drones come from drone comb, we know this. Varroa prefer drones. If I take a drone frame, a frame that has only drone-sized cells, and I put that into a colony, the queen's going to fill it up with drone eggs, the workers are going to make a bunch of baby drones, they're all going to have their very last day where they're uncapped, and a bunch of Varroa mites are going to smell them and go, hey, this is great, I'm going to have a whole bunch of daughters in there. They run in, the cells get capped, and then two things can happen. Number one, I can take that frame out, I can put it into my freezer or just throw it into my chicken yard, and I can kill all of those mites and all of those drones. Now, it's not that there's no cost here. All of the protein, all of the effort that went into raising those drones clearly cost the hive something. But I'm going to be removing a whole lot of Varroa mites, and I'm not putting in any chemicals, I'm not buying anything other than this drone comb. So it can be a decent way to pull some of those mites out, reduce that mite pressure. I have never met anyone who uses nothing but the drone comb trapping method and controls their Varroa mites sufficiently. I have met a lot of folks who use this as part of their mite management, and they do successfully pull out a whole bunch of their mites, and they don't have to treat as much with other methods or techniques. I said two things can happen. Thing number one is that I go out and pull that frame out when they all get capped, and now I've removed a bunch of mites. The other thing that can happen is I can sprain my ankle, and then I don't have a friend to go out to the apiary for me, or maybe I didn't take good notes, and I can't remember exactly when they're supposed to get capped. And now what I've done is I'm going to have these drone cells opening. I'm going to have these drones crawling out, and huge numbers of mites crawling out with them. Do you remember that experiment where I told you that I had a whole bunch of colonies that had lots and lots of Varroa mites? How did I get that? I started with high mites in the spring, and then I just gave them as much drone comb as they would tolerate, and I made them make as many drones as they possibly could. And that was how I got those mite levels that got so high that all of those colonies were dead at the end of that season. So you've got to make sure if you're doing this that you really understand how long does it take before a drone gets capped? How long after a drone gets capped does it emerge? And that you are working within your windows. And even if it's raining, and even if your leg hurts, and even if you've got other things that come up, you better make sure you get out there and pull those drone frames. The other method you can use is trying to reduce the bee population growth. And this is sort of a tricky method to understand, and it's not for everybody, but it's something to think about. We know that if you have a smaller colony, maybe a colony that's only in a single deep brood nest, what you're going to have is a colony that's probably going to swarm, and it's probably going to become honey-bound. They'll bring in so much nectar that they can't make any new brood for a period of time. Both of those things will lead to a brood break, an interruption in that continuous bee population growth that also interrupts the continuous mite population growth. This is a graph from an experiment where we've got two different populations of colonies. The red line is showing you big colonies that were given double deeps and as many supers as they could tolerate. And then the green line is showing you a bunch of colonies that were just living alone in single deeps. And what we see here is that over the course of, we start in July, and we jump to the next year, and then we've got May, June, July, August, September. We see that for the most part, the number of mites that we detect on those big colonies is just climbing and climbing and climbing and climbing. The number of mites that we detect on the small colonies remains relatively low. It's below 2%, until it suddenly isn't. When is that? September. What happens in September in Ithaca, New York, where this experiment was done? All the goldenrod dies, and then the robbing begins. These are all in the same apiary. And so what happened, we believe, is that these healthy little colonies went in, and they robbed a whole bunch of honey, and also picked up a bunch of mites from these sick colonies, these big sick colonies next door. And so this is one method that you could use. It's what's probably happening in nature. It's probably how bees that are living in bee trees out in the forest are helping to keep their mite levels from skyrocketing each year. But if you're a beekeeper who wants to make honey, if you're a beekeeper who wants to have big colonies, this might not be the method. But it's important to understand how it works. There are some methods that you could consider using. One of them is reducing your bee population growth by caging your queen for a period of the year. interrupting that brood growth cycle for a period that's going to allow the colony to go broodless. Well, if the colony goes broodless, for one, you can go in, you can treat them with Hopguard or oxalic acid. And beyond that, just by making that colony go broodless for a period of time, just by limiting the queen's ability to have that continuous chain of brood, you're going to have varroa mites walking around saying, oh, I'd really like to reproduce. I'm all swollen up with nutrition. Where am I supposed to go? And that gives your bees a chance to catch those mites and bite their legs off and throw them down to the bottom of the colony. So we've got a couple of different methods here. This is a push-in cage that you can use to cage your queen on just a little bit of comb. This is a single frame queen cage. You just drop a deep frame right into that. This is something that Better Bee has just started carrying, and that we're ordering as many as we can so that we can pass them on to you. They're actually manufactured in Europe, but we work with the supplier to make these excellent cages so that I can seal my queen up. She's in that cage. She can lay as many eggs as she wants on that one frame, but there's no more brood being produced in the rest of the colony. I can then take that one frame out and throw it away or do whatever I want to do. Maybe I put a drone frame in there. So now my queen is laying nothing but drone eggs. I take the drones out. Now there's no brood. I can get them with an oxalic acid treatment. There's a lot of methods you can use if you can seal your queen away. And this graph, very quickly, and I know I'm flirting with disaster by running out of question time, but I want to give you a chance to answer or to ask questions. But what this graph is very quickly showing you here is the number of mites that were falling under colonies that were given all sorts of different treatments. And what I want to emphasize here is this line here, the blue line with these squares. We see high varroa levels here, and then when the BI, this is brood interruption, aging of the queen, is taking place, we see fewer and fewer and fewer mites falling until the mite levels are way down here. These were methods that involved brood interruption plus an oxalic acid treatment. That's the green line and the blue line. And what you see is that we have a lot of mites fall when you put that treatment in, and then the mite levels plummet. And so this was the best control that was seen here. It all involved this queen isolation, this brood interruption by caging. And the last method you can use is splitting your colonies. If you split colonies to manage swarming, you should keep in mind that when you split a colony, if you are allowing them to requeen themselves, if you're breeding your own queens, if you give that colony a brood break, if you give that colony a period where they don't have any capped brood, and you hit them with an oxalic acid treatment or a Hopguard treatment, you have really combined your management with some of those chemical controls in a way that's going to allow you to keep your mite levels much, much lower and much, much more efficiently. And so what I want you to think about now is both those miticides and some of these management techniques as different tools in your arsenal. They're all good to understand. You can misuse them. They might conflict with each other, but they also might synergize with each other. They complement each other. And if you just sit around waiting for a silver bullet to control varroa mites, you're probably never going to get one. We've wanted one for decades. We wanted one for not as long as I've been keeping bees. We've wanted one for as long as I've been alive. And we just haven't had one. So if you're just thinking, well, they just have to make the right chemical, or I just have to learn this one neat little trick, you're not going to be able to manage your varroa well. Your goal isn't to kill them all. Your goal is to manage them. You've got to know what the levels are. You've got to know what tools you can use to make those mite levels go down. And then you've got to be able to effectively control them. I'm going to jump ahead. The last thing that I want to very briefly talk about is the idea of having mite-resistant bees. And so there's a lot of different breeding programs around the world that select for a bunch of different mite-resistance traits in honeybees. A couple of words you might have heard are hygienic bees. Someone talks about hygienic bees, they're probably talking about the freeze-killed brood assay, the freeze-killed brood test. You take a thermos of liquid nitrogen, you take a piece of PVC pipe, you press it into capped brood, you kill them with the nitrogen, you put it back in the colony, and you come back the next day. And you say, how many of these cells did those bees walking over go, that smells dead, let's open it up and rip it out. This is a colony that's pretty darn hygienic, because they've ripped out almost all of those frozen cells. You might also hear people talk about VSH, or Varroa-Sensitive Hygienic. It's the same idea, it's roughly the same behavior. It's that these bees are going in, smelling that something's wrong, and then opening up the brood and pulling them out. The problem is this is a lot harder to test for. So a lot of queen breeders don't mess with it, because what you need to be doing is testing not just do your bees smell that there's a bunch of dead frozen pupae underneath these caps. you need to figure out if they're selectively removing cells that have Varroa inside of them. So it can get a lot harder to evaluate this. There's grooming. You might hear about people talk about the ankle biter line or the Purdue ankle biters. This is one of the breeding programs focusing on grooming. And in that, it's just what it sounds like. It's mites that are riding around on the bees, getting scraped and scooped off by the bees. The bees are biting the legs off of those mites before they throw them down into the detritus at the bottom of the hive. This is a quick video that will show of some bees from an ankle biter lineage. We can see she's not interested, but she's going to save the day. Runs over and attacks that girl. Now, the trouble there is actually, if you look closely, you'll see that that mite doesn't get killed. That mite gets grabbed and immediately jumps onto that bee's face and then climbs on behind her eyes. And so remember, these mites are good at what they do. What they do is survive and reproduce. There's also this uncapping, recapping trait. I won't belabor the point. It's just, again, it's a method where these bees are going in, they're opening up cells that may have mites inside of them, and then they might pull out the brood or they might recap them again. That can interrupt mite reproduction. The last thing I want to very quickly talk about is this idea of Russian bees or survivor bees, some population of bees that might be naturally resistant to Varroa mites. So remember, we talked about the history of these mites. We talked about the fact that Vladivostok, Russia, right over here, is probably where the Varroa mites first got onto European Western honeybees. Well, there were still Western honeybees in Eastern Russia. So if you went over there and you took some of those bees, you might imagine that they would have had the best opportunity to evolve some kind of mite resistance traits because they didn't have any chemical treatments for decades, for basically the better part of a century. And so that's exactly what was done. The Russian bee lineage involved going to Primorsky, Russia, right up here, grabbing some bees that were somehow still alive with the Varroa mites, and then bringing them to the United States and organizing a breeding program around them. The idea here is essentially, maybe we can become better beekeepers by figuring out what nature is doing without us. If we go in and we say, what would nature, we don't really know what we're doing as beekeepers until we know what nature would be doing if we were doing nothing. So we just look at these survivor bees, we figure out what they're doing on their own, and maybe we can learn some important lessons from them. This is a map of all of the survivor bees around the world. You will notice that one of these populations is in the Arnott Forest in Ithaca, New York. You might remember that I got my PhD in Ithaca, New York. What I'm unfortunately not able to cover today is all of my doctoral work with Tom Seeley on the survival traits of those Arnott Forest bees. But I will quickly summarize and tell you that wild swarms that you catch, not just my bees out in nature, but the bees that you find next to the nature preserve or out in the state forest or wherever you put up your swarm traps, those bees could carry disease. They could be riddled with Varroa. They might have American foul brood. So you better put them in a quarantine yard. You don't want to bring them right into your apiary and spread disease. But don't dequeen them the second you find them. Because the queens that are in those colonies could have really valuable genetics. They could be more mite resistant than the rest of the bees that you're working with. Everyone says, oh, well, now we've talked about the Arnott Forest bees. We've talked about these resistant bees. Can any bees be like them? Yes. If you catch interesting bees in the environment, they might be valuable to you. Can my bees be survivor bees? If these bees can survive without treatments, do I really need to treat my bees? And so I do like to very quickly just warn people against uninformed, treatment-free beekeeping. So there are folks who will talk about treatment-free beekeeping. Some of them have a lot to say. They've got a whole complicated breeding plan. Other folks are just lazy or uninformed. They just think, I don't have to treat because I don't want to, and I just won't, and we'll see what happens. The problem there is that you're really producing Varroa mites that are going to become the problem of all of the other bees in your neighborhood. If you want to be a treatment-free beekeeper, you've got to have a great understanding of mite biology, a great understanding of bee biology. You've got to know a lot about pathogen-host evolution. You've got to really do your reading, really do your studying. And you either need to be the only beekeeper within miles, so that if all of your bees die from Varroa mites, it's only your problem. Or you need an agreement from every single one of your neighbors to go treatment-free. There are places where this is happening. There are islands in Scotland or peninsulas in Wales where folks have decided they want to try to go treatment-free. They're going to let a lot of their bees die, but then they're going to see if they can get any of those bees to survive. If they breed from those survivors, maybe they'll be, a little more or a lot more Varroa resistant. So if you are a treatment-free beekeeper and your treatment-free mite management strategy is less complicated, requires less thought, less research than just buying some treatments and treating your bees, you're not doing it right. It's not the easy route. It is very much the hard route of beekeeping. If you are a queen breeder and you're really diligent and on top of things, treatment-free can be a reasonable strategy for you to produce a higher quality queen bee. If you are a backyard or homestead beekeeper, I do not recommend treatment-free beekeeping because there's a lot that can go wrong, and it's unlikely that you're going to be able to do it in the same responsible way that a full-time professional queen breeder can devote to it. So, miticides, management techniques, and partially, but not fully, mite-resistant bees are all weapons in your arsenal for controlling and managing varroa mites. And I suggest that you understand them all, that you incorporate them all into your management plan, and then you create a management plan that's going to allow you to really control these parasites. The last thing I'll emphasize here is just that in Better Bees' monthly newsletter last April, April 2021, we had an article entitled Making a Varroa Management Plan Before Beekeeping Season. Before things really get started, building that Varroa plan. And we had this quote here. We said, what? Varroa? Isn't that a problem for September? Not if you want to keep your bees alive until next spring. Controlling Varroa in the fall is a great way to have no bees the next spring. Controlling Varroa in the spring and the summer and the fall and the winter is a really good way to eliminate Varroa as a likely cause of death for your bees. So I just want to emphasize that, I don't want to look like a shameless corporate stooge here working at Better Bee. But I have some control over the Better Bee catalog here. I saw that there were some free ones up on the registration table. In this, we've got a central section that I'm really in charge of. There's no products on these orange pages in the middle. This is just a beekeeping guide, helpful tips, helpful articles. We've got advice on how to do a sugar roll correctly, how to do an alcohol wash. We talk a little bit about Varroa biology and Varroa management. And so one of the things in here is a sample Varroa management plan that we recommended. It goes from the start of the year all the way through to the end of the year. This is not the plan. This is not the only plan that you should use. But it's something that you can look at and say, well, I don't like that part of it, but what if I tweaked mine this way? What if I modified my plan and I plan to do that? But it encourages you to be testing, to be monitoring, and also to be treating throughout the year. All right. Jump quickly and just acknowledge all of the folks who have contributed to this. Thank you, Better Bee, for hiring me. Thank you, all of you, for having me, and the Dunns for hosting me at their house. These are the various funding sources that have supported some of my research. I'd like to thank the Varroa Mite for giving me something to talk about all the time. And I want to thank you. So I'm happy to take questions now or later.
Q&A.
All right, let's jump to the Q&A. If we don't get time to cover anything, or if you need to contact me otherwise, you can write this down. education@betterbee.com is an email address that goes right to me, and I'm always happy to answer folks' questions or carry on discussions. Yes?
What's the lifespan of a Varroa mite?
Lifespan of a Varroa mite is hard to answer definitively. In the same way that it's hard for me to say that they tend to go through 3 reproductive cycles in their life, it's very difficult to study a Varroa mite naturally in a hive and track one individual parasite whose whole life is spent either hiding in a cell or hiding underneath the abdominal plates of the bee. We don't know for sure. We've done some studies that have suggested that the typical Varroa mite in summer is probably living for something like a month or 2. We also know, obviously, that if the Varroa mites can only reproduce in brood, and your colony stops producing brood for 6 months out of the year, 4 months out of the year, however long your broodless period is in the fall and the winter. If you still have Varroa mites at the end of the day, those mites were born, sometime the previous fall. So we know that they can live for multiple months, but that the typical mite, just like a worker bee, during the summer, because there's a lot more activity, is basically going to be burning herself out faster. Sure.
So I've got 3 questions related to mites feed.
Okay.
So the first one is, how many hours or days does a mite feed at one time?
So the Varroa mites are riding the bees that they're infesting more or less continuously. And so if they're feeding on a worker bee, they are going to be wedged underneath those abdominal plates, and they're not going to leave until they're ready, more or less, as far as we can tell, ready to leave and go start reproducing. How long are their mouth parts actually in contact with the bee? I'm not sure. It may very well be continuously. I don't know. I think Sammy Ramsey would be the only person I would trust to answer that. I've never heard him give an answer on that.
And so this is kind of related, so how long do they have before they have to feed again? So you don't know how long they feed for, or how many,
We know that varroa mites will die if you separate them from a food source. The longest I've ever kept one alive was 9 days in the lab.
Okay.
I think that's very unlikely. I think the typical varroa mite, out in the environment or moving around, if there's no bees to feed on, is probably dead within 3 days. But I think that like a lot of insects or like a lot of arthropods, they have a pretty good ability to just buckle down and say, there's no food coming in, so let's not burn too many calories, let's not move, let's just wait until we can feed. So they've got a little bit of a...
So just to reiterate, so there has not been any studies done in marking individual mites to see how long they actually feed before they disperse?
I know some people who have done that. I can't think of any published studies that have really satisfying stories from that research. We get tiny little pieces of information, but we don't yet have a really clear, crystal clear understanding.
The reason why I'm curious is because you mentioned about mite load and how they feed on multiple bees. So I'm just wondering how many feedings per dispersal cycle they might have to see what one mite's viral load might, contribute to the
Right.
bees in that colony.
I know that Marla Spivak has published some sort of modeling papers where they take some little snippets of data and try to put it together, and so that would probably be where I would look first. But I don't know of any more robust work that's in that sense. Sure.
I've seen articles from the Washington State University who are working with a fungus. Are you aware of that?
I am aware of that. So that's work that involves Paul Stamets, who's a very interesting mycologist who's done a lot of great stuff. I've got a couple books by him at home. What they observed was that if you take certain kinds of fungus, like a wine cap fungus growing out on sawdust, and you break it, and all of those fungal sugars are available, honeybees will come and forage on that. And so that was what triggered them to think, well, what if we found some medicinal mushroom that we could give to bees? The actual research that's been done on Varroa control using these fungal extracts or using live fungus is not nearly as well developed. And what has come out so far, I think, is really pretty preliminary. As far as I can understand it, what they've demonstrated is you can take a Varroa mite, put it in a covered fungus spores, and then it will get killed by the fungus. That's not really impressive. I can take one of you and put you in a petri dish and fungus. What they need to figure out is whether they can get a good distribution method to get it into the colony, to have it kill the mites and not kill the bees. And I just haven't seen it yet to say this is going to do it. Even if it does, I suspect it would just be one of a number of mite control tools that you would still want to use in your mite management. Sure, right there.
Last question.
The varroa mite is a vector of viruses. What about my extracted wax spraying, putting that back into a new hive?
There is, virology labs can detect these honeybee viruses on equipment like that. They are not detecting viruses that are high enough that they are likely to cause harm to the bees. And it's important to understand that these viruses, things like deformed wing virus, that's not a virus of varroa mites. That's a virus of honeybees. That's a honeybee virus that we know the honeybees have had since long before the varroa mites ever got onto them. And that was a virus that didn't really cause much harm because it only spread when adult bees were standing tongue to each other, regurgitating food and then absorbing food from each other as they were processing nectar. And so some amount of these viruses being present on your wax, in your honey, bee to bee, that's not going to kill a colony. The thing that kills it is, just like somebody using a dirty syringe to shoot up IV drugs, these varroa mites are going from healthy bees, young bees, old bees, all over the place. And that's what's really driving that huge increase in the viral load per bee.
Thank you.
That's all.
Yeah.
All right.
We're going to probably have this young gentleman doctor back again to get so much information. So we can just give him a thank you.
Northwestern Pennsylvania Beekeepers Association.